The last video today is about solving equations with variables on both sides. This is section 4 of chapter 2. Good luck. The fourth video in this very straightforward series on solving equations has to deal with solving equations with variables on both sides. Now, 3 different examples. In the past, your teachers have shown you, or I'm showing you for the first time, what to do when on the middle part, let me rephrase this. On both sides, I'd call it the left side and the right side, you have variables on both sides. Now there's a variety of different things that you can do, but the traditional technique, at least as far as I'm concerned, is to simplify the individual sides, whether that means distributing or combining like terms or both, and then getting rid of or eliminating the smaller of the two variables. And what I mean by that is find the two variable terms, in this case 5x and negative 2x, and whichever one has the smaller coefficient, in this case negative 2, that's the one you eliminate. Now to get rid of the smaller coefficient or the smaller variable term, I'm going to simply do the opposite of it. If it was minus or negative 2x, I'm going to do positive 2x. I'm going to do that to both sides, draw my line. I'll get 7x plus 2 is 9, and at this point I would subtract 2 to both sides. That would give me 7x is 7. I would divide both sides by 7 and get x equals 1. You can see that I'm skipping some steps here because those are some steps you've known for a while. You can also go back to previous videos and follow how those work. But with that in mind, if you were curious about how the check works, you would take the 1 and put it in the 5. Put the 1 in the x spot and do 5 ones is 5 plus 2 is 7. On the other side, you'd put 1 in here and get negative 2 times 1 is negative 2. Negative 2 plus 9 is 7. So both sides equal 7. And when you get 7 equals 7, after substituting this in, you end up with one solution. And that solution is that x is 1. That's the only number that will ever make this equation true. It's kind of unique. 1.1 won't work, 2.7 won't work. Only the number 1 will ever work. Now I bring that up not because it sounds like it's a earth-shaking understanding, but because you're going to see something different here in a moment. And because of the paper and I don't want to clutter things up, I'm going to switch colors. I'm going to go to this next question. Now I had mentioned a few moments ago that the first step should be simplifying the two sides. And in this problem I see that the right hand side could use some simplifying. So I'm going to rewrite the left and I'm going to distribute the right, and I get this. Now these two sides look, gosh, I don't know, they don't look all that much the same. So now I'm going to refer back to, if I have variables on both sides, the right and the left, I look at the coefficients and find the smaller one and get rid of it. Well, you could argue here that the coefficients are exactly the same. This has a negative, so you could argue it's negative 1, and this one has negative, so it's also negative 1. So what do? Well, if you're not sure, eliminate the small variable. They just happen to both be the same thing, and you get 3 equals 3. Now that's a really curious answer to this equation because it doesn't seem like much of an answer. In the previous problem we got x is 1. That's a nice clean statement of an answer. In this statement what we find is 3 equals 3. Well, no joke, 3 equals 3, so what does that tell us? What that tells me is the left-hand side of the equation and the right-hand side of the equation are exactly the same. And it also tells me that no matter what x could have been, x gets eliminated anyway. So the number that goes in place of x is really irrelevant, which means you have an infinite number of solutions. In math class, you might call it IMS for infinitely many solutions. Your teachers might call it a variety of different things, but the telltale sign of an IMS or an infinite number of solutions type of question is that as you work the problem, your two sides end up being exactly the same. So I'm going to write two sides equivalent. If you get two sides that are equivalent, as you're solving the problem, you have an IMS or an infinite number of solutions. If you have the value equals a number, then you get one solution. And I'll switch back to black again for the bottom. Or maybe I'll use pink. Pink's fun. Now in this problem, look what we have. We have a similar situation to the previous one in that though we don't have any simplifying to do to the right or to the left side, we do have this situation where the variables on both sides have the same coefficient. So I'm going to try the same strategy as last time, simply get rid of them and see what happens. Now in this problem, I get a similar type of strange statement at the end where the variables are all gone, which means I don't have one solution. I have something other than one solution, but I have a statement that's inevitably not true. 1 does not equal 1,000. What that tells me is, just like here when 3 equaled 3, and that meant the left side and the right side were always the same, what I think I observe here is that the left side and the right side are always different, and once again, the x value is irrelevant. So what I'm going to write for this one is going to be no solution. There is nothing else. Some teachers will accept NS as an abbreviation. That's fine. And the telltale sign of a no solution, you can see the sunshine's coming out, is when the left and the right-hand side end up with numbers that are simply not the same. Again, no variables to deal with, so that's why this ends up being no solution. Good luck with your solving equations with variables on both sides.